My dear students, let me consider some more examples from the in extension of the previous class. Out of it, the example is taken in connection to some industry related, and the example is given as the following data gives the variations of a periodic current over a period, and the first row will be in terms of t second, second row will be in terms of amperes. For 0 it will be 9. For 0 0 second amperes will be 9.0. For t by 6 18.2. For t by 3 24.4. For t by 2 27.8. For 2t by 3 27.5. For 5t upon 6 22.0. For t it will be 9.0. And the question is, find numerically the direct part of the variable current and obtain the amplitudes up to the second harmonic. Okay, we just observe this example in extension of the previous one. Last day we have seen the same type example. What is the special nature of this example? You just observe here the first and last terms. The first term is 0, last term is t. For the 0 amperes will be 9.0. Again for t at the end it will be 9.0. This means what? Both initial point and end points are coincide. That is why it says that it completes one cycle. To define a cycle, what we are doing? We are considering either initial point or end point to define that circle. And the solution is given as we observe that the value of a at t is equal to 0 and t is equal to capital T are the same. You just observe here, my students, small t will be the variable, capital T will be the parameter. Okay, do not confuse them, do not mix them. Hence, we shall omit the last value. For convenience, we are omitting the last value. Why we are omitting the last value? To define the circle. Okay, therefore, we convert a is equal to f of t to the period 2 pi by putting theta is equal to by putting theta is equal to 2 pi into t upon t, so that we have theta is equal to 0 when t is equal to 0 and theta is equal to 2 pi when t is equal to t. You just observe here, there is no new thing here. This is the same example as the previous one. This example is I have taken from the BS Grade of Higher Engineering Mathematics. You can see this example may be solved in some other good authors also. The only special nature of this example is what? Both initial point and end points are coincide. Instead of the variables x and y, they have given with t and a. Okay. Then the corresponding values of theta are respectively 0 degree, 60, 120, 180, 240, 300, 360. You can observe the last example. The same example I have taken with some little more explanation. The Fourier series up to the second harmonics. The Fourier series up to the second harmonics is given by, what is the second harmonic? Capital A. Instead of A, what you have written in the last example, it is Y. It was Y. Here we are writing A, capital A, is equal to A naught by 2 plus A1 cos theta plus B1 sin theta, okay, plus A2 cos 2 theta plus B2 sin 2 theta. Refer, my dear students, this is a very special nature of the second harmonic example. For every either first or second harmonic, you need to write this formula completely and neatly. Without this example, you cannot solve the example in any manner. Especially for the numerical values, this example is very relevant. Okay, now we prepare the relevant table considering the values of A and theta in the interval 0 is less than or is equal to theta, E is less than or is equal to 2 pi. The same example I have taken from the previous one. Okay, since the data is shown in the previous example, we just observe here, refer the same example. The Fourier series is given by after calculation. What is A naught, what is A1, B1, A2 and B2. We are substituting the values here. The first condition will be A0 by 2 plus A1 cos theta plus B1 sin theta plus A2 cos 2 theta plus B2 sin theta sin 2 theta. A0, A1, B1, A2, B2 have been taken from the previous example. The direct current part of the variable current is the constant term in the Fourier series, that is 21.4835. That is A0 by 2. The constant term is 21.4835. One more example is added here. What is that? Amplitude of the first harmonic. What is the formula for this one? It will be root of a1 square plus b1 square. This term will be a1 and b1 are given here, taking their root of squares of sum of their squares. It will be 8.455. Similarly, amplitude of the second harmonics is root of a2 square plus b2 square. This will be 3.09. This is a very special example where actually in generally amplitude of the first harmonic or second harmonic may not be taken as a question. That's why I chosen this example from other textbook. Please go through the example correctly and neatly in a relevant manner. Do the calculation of your own. Change the mode of your calculator according to the requirement. Okay. Do not buy the terms. It is not necessary also and it is not possible also. Do the calculation of your own style to get the value correctly and neatly. One more condition I want to put the restriction at the end, that any value shall be taken up to minimum 3 decimals. Minimum 3 decimals. So in some books they have been taken with the 4 decimals, and some books you have been taken with the 2 decimal. No problem, but you need to take up to 3 decimal, and it should be precious value. Okay, thank you.